Assalamualaikum and hi, my name is Muhammad Sofi Manda, also representing my co-author in this study. I want to share what that we have found in our study regarding the cutaway observation on thin slag polymer concrete to look for thin slag particle distribution throughout the thin slag polymer concrete column sample. Before moving further, let's get acquainted with thin slag polymer concrete. First, thin slag is an industrial waste from tin smelting industry. Most of thin slag waste is dumped in a controlled area due to its hazardous effect. Malaysia used to be one of the largest tin manufacturer, but now we can say that Malaysia is one of the tin production country. Actually, according to a report, Malaysia has produced about 23,700 tons of refined tin. So from that amount of refined tin, we can imagine that the tin slag waste, which is usually much more than that. Right now, tin slag is dumped in a controlled area, although there is people who look for it for rare earth material extraction such as niobium and tantalum, but the cost is too high, which make most of tin slag remain in the dumping area. The consequences of that situation have given a threat to pollution on the soil and underground water from tin slag dumping area. Therefore, for sustainability, we have introduced to consume tin slag waste as aggregate in polymer concrete. To fabricate tin slag polymer concrete, is generally start with pre-treatment of tin slag, raw tin slag, which involve drying and crushing it into fine particles. Then the fine tin slag particles is mixed with polyester resin and cast into specimen mold. Right now, most of tin slag have been applied in the fabrication of a short and circular column sample, which is known as a circular thin slag polymer concrete short column specimen. The specimen have been through a series of mechanical testing to investigate its potential. This is some of a preliminary study on thin slag polymer concrete which involve experimental and numerical analysis on thin slag polymer concrete behavior under compressive loads. The results indicate that thin slag polymer concrete have a good compressive strength and have the potential to become alternative aggregates in polymer concrete for the sake of sustainability. This study have provide solutions to the previously reported hazard due to an increasing of tin slag dumping in terms of waste management. The failure mode of test samples have shown crushing failure on the middle of the test sample, but some of other test samples have exhibit cracking and shear failure. Therefore, to confirm the general failure mode to be assigned as thin slag polymer concrete failure specification, there was a need to investigate the thin slag particle distribution throughout the material. Actually, raw tin slags are available in variety of shapes and size from 3 mm to 10 mm and even larger than that. For tin slag polymer concrete, the tin slag particle was crushed into fine particles of less than 1 mm in size. The configuration between tin slag particles and matrix resins was observed under microscope to magnify the image across the test samples from top to bottom and left to right. The sample was cut through a splitting cut in longitudinal directions and saw cut in transverse directions. That was the variations of test samples which will be observed for thin slag particle distributions investigation. This is the first variation of test sample in this study for splitting cut, and the location to be magnified was divided into 8 locations as shown in this figure, and the location is named as T1L, T1R, T and so on, which T represent top, and R and L represent left and right sections of the test sample. And this is another variation of test sample which is involve a saw cut. For saw cut, the test sample was cut on 2 points to produce top, middle, and bottom section in transverse direction. Each of the sections were further divided into left, middle, and right areas. So each section will have 3 locations, which in total 9 locations that involved in the magnification of the image. Now come to the results. This is the magnified image of the first variations of a test sample in the study, which involve a splitting cut sample. The image was analyzed to extract pattern variations based on shape and color. Detailed observation on all of the images have spot 4 patterns. First is a dark round shape, and then second is dark angular shape. Third is white random shade, and fourth is brown random shape. The classification of that 4 image patterns was then assigned with potential element as shown in the tables here. For white random shade, it is actually the metric resins elements. For dark round shape, it's porosity or voids. For dark angular shape, it's fine thin slag particles, and for brown small random shade, it is the silica from thin slag. Next, this is the magnified image of the second variation of our test sample in the study, which involve saw cut. For saw cut sample, the figure have shown all of the 9 images based on locations. A little bit unfortunate, the image of saw cut sample are not as clear as splitting cut sample. However, we still try to provide little discussions on the results. Here we have chose the middle location on every section, top, middle, and bottom, to compare the image pattern and summarize its condition. For top section, image have shown less white film layer because the top section surface was not undergoing saw cut. Dark color indicate thin slag, brown indicate silica, and white indicate metric resins. Saw cut has swept away the metric resin element due to friction and heat generated, causing a thin dull white layer which blocking the view. Behind the layer, the image on middle and bottom section was approximately similar with top section. In terms of particle distribution, the appearance on top, middle, and bottom section indicate similar pattern, which confirm uniform distribution of the thin slag particles in uh, in thin slag polymer concrete sample. For conclusions, first, let's say that the study of thin slag particle distributions on thin slag polymer concrete circular column sample have provide good findings. Split cut thin slag polymer concrete image have provided a clear view Saw cut shows thin dull white layer which blocks the view. The appearance on the top, middle and bottom section indicate similar pattern. The aggregate distribution is evenly distributed throughout the thin slag polymer concrete material. Further experimental studies in analyzing the particle distribution in thin slag polymer concrete is recommended by employing higher capacity imaging tools such as a scanning electron microscope to confirm the finding of this experimental study. And I think that's all from us. Thank you very much.